Hey everyone, welcome back to Simple Understanding Channel. If you're preparing for the APICS Certified in Logistics, Transportation and Distribution (CLTD) exam, or planning to start soon, you're in the right place. This video is part of our CLTD learning playlist, where we break down complex logistics and distribution concepts into clear, practical lessons. Today, we're focusing on something that often challenges many test takers: quantitative and analytical problem solving. We'll go step by step through 10 realistic CLTD-level math problems, each one carefully designed to reflect the actual exam's logic, style, and difficulty. You'll learn how to interpret real-world logistics scenarios, think strategically like a logistics manager, and make accurate data-driven decisions. And remember, this video is just one part of the complete CLTD study materials bundle that I've built to help you master the entire exam, not just the math section. Inside the bundle, you'll find concise notes, visual summaries, process maps, question banks, mock exams, and detailed step-by-step problem solving. Everything you need to understand, practice, and pass the CLTD exam. You'll find a download link in the description below, along with the full CLTD playlist, so you can study each module at your own pace. So, grab your notebook, pause whenever you need to, and solve along with me. Let's get started. Here are your top 10 CLTD math problems, explained in the clearest and most practical way possible. Problem 1. Transportation cost comparison. A company needs to move 500 tons of freight from Chicago to Houston. If the shipment travels by rail, the cost is 9 cents for every ton per mile, and the total distance is 1,200 miles. If the shipment goes by truck, the cost is 12 cents for every ton per mile, and the distance is 1,000 miles. Which transportation mode provides the lower total cost, and by how much? Problem 1. Transportation cost comparison. Data. A shipper needs to move 500 tons of cargo from Chicago to Houston. If it travels by rail, the cost is 9 cents per ton mile for a distance of 1,200 miles. If it travels by truck, the cost is 12 cents per ton mile for a distance of 1,000 miles. Which option provides the lower total cost? Explanation. Problem 1. Let's start by comparing transportation costs. We'll find the total cost for each mode by combining the cost per ton mile, the distance, and the shipment weight. When we multiply these values, the rail shipment ends up costing around $54,000, while the truck shipment costs about $60,000. So, the rail option is cheaper by roughly $6,000, making it the better choice for this move. Problem 2. Break-even transportation quantity. A manufacturer can choose between two shipping options. A full truckload costs a flat rate of $1,200 per shipment, no matter how much is loaded. The less-than-truckload option costs $150 for each ton shipped. At what shipment weight do both options cost exactly the same amount? Problem 2. Break-even transportation quantity. Data. A manufacturer can ship products using truckload service or less-than-truckload service. A full truckload shipment costs $1,200 flat, regardless of weight. The less-than-truckload rate is $150 per ton. At what shipment weight do both options cost the same? Explanation. Problem 2. Here, we're looking for the point where the total cost of both shipping methods is equal. That's the break-even weight. We set the flat truckload charge equal to the variable less-than-truckload rate. At $150 per ton, the break-even point occurs at 8 tons. That means for any shipment heavier than 8 tons, it's more economical to use a full truckload. If the shipment is lighter, the less-than-truckload option saves money. Problem 3. Inventory carrying cost. A warehouse holds an average of $2 million worth of inventory throughout the year. The annual cost of carrying inventory, which includes storage, insurance, and the cost of capital, is estimated at 24% of the inventory value. How much money does the company spend each year to carry this inventory? Problem 3. Inventory carrying cost. Data. A warehouse holds an average of $2 million in inventory, and the annual carrying cost rate is 24%. How much does the company spend each year to carry that inventory? Explanation. Problem 3. Inventory carrying cost reflects how much it costs the business to hold goods in stock, including storage, insurance, and cost of capital. To find it, we multiply the inventory value by the carrying cost rate. 24% of $2 million equals about $480,000 per year. That's the annual cost of keeping that inventory sitting on the shelves. Problem 4. Warehouse productivity. A warehouse employs 20 workers, and each one works 40 hours per week. During 1 week, the warehouse team processed 8,000 customer orders. What is the warehouse's productivity in terms of the number of orders completed per labor hour? Problem 4. Warehouse productivity. Data. A warehouse has 20 employees, each working 40 hours per week. In 1 week, the team processed 8,000 customer orders. What is the productivity in orders per labor hour? Explanation. Problem 4. Let's measure how efficiently the warehouse staff works. First, we calculate the total labor hours by multiplying the number of workers by their weekly hours. That gives us 800 total hours of work. Next, we divide the number of orders processed by the total hours worked. 8,000 orders divided by 800 hours means they're completing about 10 orders per labor hour. That's a solid productivity rate for a well-organized operation. Problem 5. Economic order quantity for replenishment. A distribution center uses 36,000 cartons of product each year. Each replenishment order costs $75 to place, and keeping 1 carton in stock for a full year costs $3. What order size would minimize the total annual inventory cost? And how many orders should the company place each year? Problem 5. Economic order quantity for replenishment. Data. A distribution center uses 36,000 cartons of product each year. Each order costs $75 to place, and holding 1 carton for a year costs $3. We need to find the order size that minimizes total cost and how many orders should be placed annually. Explanation. Problem 5. The goal here is to balance ordering cost and storage cost. If we order too frequently, we spend too much on order processing. If we order in large batches, inventory sits too long and increases holding cost. Using the economic order quantity formula, the most efficient order size comes out to about 1,340 cartons. That means the center will place roughly 27 orders per year, striking a balance between replenishment and storage expenses. Problem 6. Transportation load utilization. A truck has a maximum weight capacity of 24,000 kilograms and can hold up to 90 cubic meters of space. A shipment consists of 800 cartons. Each carton weighs 28 kilograms and takes up 1/10 of a cubic meter. Which factor limits the load, weight, or volume? And what percentage of the truck's capacity is used? Problem 6. Transportation load utilization. Data. A truck can carry up to 24,000 kilograms or 90 cubic meters of volume. A shipment includes 800 cartons, each weighing 28 kilograms and taking up 1/10 of a cubic meter. We need to determine whether the shipment is limited by weight or by space, and what percentage of the truck's capacity is used. Explanation. Problem 6. To figure this out, we'll check both the total weight and total volume of the load. 800 cartons at 28 kilograms each weigh about 22,400 kilograms. That's 93% of the truck's weight capacity. The total volume is 80 cubic meters or about 89% of the truck's cube capacity. Because the weight limit is closer to full, weight becomes the limiting factor. In other words, the truck is filled by weight before it runs out of space. Problem 7. Warehouse space utilization. A warehouse has a total area of 60,000 square feet. Out of that, 45,000 square feet are designated for storage, while the remaining space is used for offices, docks, and aisles. Currently, 36,000 square feet of the storage area are filled with goods. What percentage of the storage area is being used, and what percentage of the total warehouse space is occupied? Problem 7. Warehouse space utilization. Data. A warehouse has a total area of 60,000 square feet. Of that, 45,000 square feet are used for storage, and the remaining space is used for offices, docks, and aisles. Currently, 36,000 square feet of storage space is filled with goods. We need to calculate both the storage utilization and the overall space utilization. Explanation. Problem 7. To measure efficiency, we first look at storage utilization. How much of the available storage area actually contains goods? 36,000 out of 45,000 square feet gives an 80% storage utilization rate. Then we compare the occupied area to the total building size, which equals 60% overall space utilization. That means 60% of the entire warehouse is filled with stored items, a reasonable level that still allows room for flexibility and operations. Problem 8. Total landed cost. A company imports parts from Asia. Each unit costs $20 to purchase. Shipping adds $2 per unit. Insurance costs 50 cents, and the import duty adds 10% of the product cost. Finally, transporting the goods from the port to the factory adds another $1 per unit. What's the total landed cost per unit? Problem 8. Total landed cost. Data. A company imports parts from Asia. Each unit costs $20 to purchase, with $2 of ocean freight, 50 cents for insurance, an import duty of 10% on the product cost, and $1 for domestic delivery. What is the total landed cost per unit? Explanation. Problem 8. Total landed cost includes every expense required to get the item from the supplier's door to the company's facility. We add the product cost, freight, insurance, duty, and inland transport. 10% duty on a $20 product adds $2, bringing the total to $25.50 per unit. That's the true cost of acquiring each imported component once all logistics and fees are considered. Problem 9. Safety stock for service level. A company sells a product with an average weekly demand of 500 units. Weekly demand fluctuates by about 80 units up or down. The supplier takes 3 weeks to deliver an order, and the company wants to maintain a 95% service level to avoid stockouts. How much safety stock should be kept on hand to meet that goal? Problem 9. Safety stock for service level. Data. Average weekly demand for a product is 500 units, with a standard deviation of 80 units. The supplier's lead time is 3 weeks, and management wants a 95% service level. How many units of safety stock should be held? Explanation. Problem 9. Safety stock protects against unexpected spikes in demand during the supplier's lead time. We start by finding how much demand varies over the entire lead time. Since weekly demand fluctuates by 80 units, over 3 weeks the variation grows to roughly 139 units. At a 95% service level, we multiply that variation by 1.65. That gives about 230 units of safety stock. Keeping this amount ensures a high service level while avoiding excessive inventory. Problem 10. Logistics network cost optimization. A company currently operates one central warehouse. Every year, It spends $500,000 on transportation and $150,000 on warehouse operations. Management is considering adding a second warehouse. If they do, transportation costs would fall to $380,000, but total warehouse costs would rise to $240,000. Should the company add the second warehouse, and how would the total annual logistics cost change? Problem 10. Logistics network cost optimization. Data. A company operates one central warehouse with annual transportation costs of $500,000 and facility costs of $150,000. If a second warehouse is added, transportation costs would drop to $380,000, but facility costs would rise to $240,000. Should the company add the second warehouse, and how would total annual logistics cost change? Explanation. Problem 10. To decide, we compare the total cost before and after adding the new warehouse. Currently, the company spends $650,000 a year. With the second warehouse, transportation would fall to $380,000, but higher facility costs bring the total to $620,000. That means overall logistics costs would drop by $30,000 per year. So yes, adding the second warehouse would reduce total cost and improve network efficiency. And that's it. Those are the top 10 realistic CLTD-level math problems, explained step by step. If you found this video helpful, make sure to like, subscribe, and turn on the notification bell so you don't miss the next lessons in this CLTD series. Remember, this video is part of the complete CLTD exam preparation playlist, which covers every topic, from logistics fundamentals and inventory control to transportation management, global logistics, and sustainability. You'll find a full playlist link and the download link for all CLTD study materials right below in the description. Thanks for watching Simple Understanding, where we make logistics and distribution concepts clear, practical, and exam ready. I'll see you in the next video.